Okay, so here we're going to talk about the event-based sequencer, and we're probably going to, well, we are going to have two videos on this. This first one is just to talk about how it works, and there is one little trick that we've noticed, and so this is just to point that out. Here, this is a document from Automation Direct, and it talks about both the drum sequencer and the event-based sequencer, event and time-based. And right here is just a description for the event-based, and you can have 16 steps and 16 outputs. 16 outputs is plenty. You might be limited in the number of steps for what we want to do. We'll have to find that out. But it's the same setup as time-based, except you click on event-based, and you have steps, outputs. Here's the output pattern. The big difference is this number 6. It says load new step number. Normally the sequencer will go step 1, 2, 3, 4. But because we have different colored cups and we want to do different things depending on what the cup color is, for instance, for the black cup we might want to go straight through 1, 2, 3, 4. For the white cup we might want to go 1, 2, 3, 6. So we're going to take advantage of that and see how that works. So this document is pretty useful, and we'll show a couple things later for what to, well, the certain thing that you need to know for the event-based. And we'll put this in the manual somewhere. So here we've got just our regular start process latch. So what we're going to do is we're going to first put in our normal lamp test timer. So we'll make that C3 over here. And then on the output we'll put our timer. And our timer has been T1. And it is 3 seconds. 3,000 milliseconds. And now down here again we'll have this our enable for our sequencer is going to be our start process, and on the output we'll put our drum sequencer. Now what we're going to do is, just like before, we're going to have our 3 light stack outputs. So this is going to be our red, output 2 will be the yellow amber, and the third one will be the green. Now I had also gone in here, and for what we want to do, I have these other, so we use start process as is C3, so I'm going to put in C4, C5, C6, and C7. Now these are just more or less wait states that I can move from one step to the next. And so my number of outputs is going to be 7, and number of steps, let's start out with 72. Now we also need, and so I need to change that from time-based to event-based, and when I go to event-based, the elapsed time and steps goes away. So we're going to make a current step. I think we had a DS3 before. Now the completion, before we had we needed completion on the output of the sequencer. So because we've used up to C7, we're going to make this C8. And okay, and we need to put these. So the first event is going to be T1, and that'll be our 3 lamps. And then what we're going to do for each step afterwards, we're just going to use C4, C5, C6, and C7. Now, so and what happens is when we first enable the sequencer, we're at step 1, which means that these 3 are on, okay? And then when it times out, T1 is the event that goes from step 1 to step 2. So, T1 doesn't make this first step happen. That makes the second step happen. So then we're just going to go down and say C4, C5, C6, and then C7. And okay, so this last step, what I want to do, so what is really happening is when T1 times out, we go to step 2, and what we're doing is we're outputting C4. Okay, that is output 4, which is C4. So that goes to the output, and then the next scan it's going to look at the input or the event. The event is C4, so that moves you to step 3. And that's what we do all the way around. So C4 makes it go, when we output C4 in step 2, It'll wrap around back to the input, and then it'll say, well, we need to move to step 3, and so on. C5 will make it go to step 4, C6 will step 5, and then it'll go to this step. Now, what I want to do here so we can tell. So, what happened is these lights go out, and these each happen for one scan. There's no way to see what's going on for that. So, what I'm going to do is I'm going to re-enable the timer, and I'm going to put on the amber light. And I'm done. So I don't need 7 steps, I need 6. So I think that's good. And when we're done, we'll see this completion flag C8. And what I'm going to do is I'm going to light the green light external to the sequencer. So what we'll see is we'll see them all on. These will go through immediately. So we'll see the yellow lamp on. So this is 3 seconds, this is immediate, this will be another 3 seconds, and then we'll get the completion flag for the sequencer, and then we'll turn on the green lamp. So, I think we are good with our sequencer. And that's all we need. So, so what I need to do is I don't want my timer to keep timing, and I really want to make this a retained timer. So, when it counts out and it gets to the first time out, I want it to stop counting. So I need to go in here and make this a normally closed contact. And this is going to be my T1 contact. So when T1 goes high here, it's going to stop the counter here. Now what I'm going to do here is, when we have a retained counter, remember, is we always have a reset. So I'm going to put my normally open contact, and that'll be for my normal reset, my system reset, which is like 003. And now for this, I'm going to put in parallel, so I need the row afterwards. And now what I want to do is I want to re-trigger with the C7. And again, this is only going to be high for one scan. So this will be a normally open contact, and this will be my C7. And now I need to do my line deal. So I'm going to put a line in there, and then I'm going to connect it over to the reset. So now what I need to do is, when I get my sequencer done, I'm going to make that a normally open contact, and that'll be my C8. And now I want to light up my coil for my green lamp, which is going to be Y003, which really what I need to do is, I want my green lamp here, but I also have the green lamp on here, and we never have an output being controlled from two different spaces. So what I'm going to have to do is I'm going to have to make this, and I'm going to change that, and we're up to using C8. So what I'm going to do is I'm going to change from Y003, I'm going to make it at C9. So now, when I'm lighting up my green lamp, it'll be from C9, okay? And what I need to do here is I need to put a parallel rung in here, and that's row afterwards. And now that'll be my normally open contact, and this will be C9. So now, and I'm going to line it up. So now, when either the sequencer is done, or when I have this bit C9, and I'll go into my address picker, and if I look in here, so I put in these wait bits in here, I put in the sequencer done. So I'm going to say sequencer green. Well, it'll be for the green lamp, so we'll know that. So we're okay with that. So now I've got, when the sequencer is done, it goes green, or when my sequencer, C9, says green, it'll go on for that too. And that'll only be in step 1 when we're doing the lamp test. So we'll get it on for the lamp test, and then we'll get it turned on when we finish the sequencer. So, let's take a look. And well, I have this from some other project that we were doing, so let me change that DS3. This should say current step. So if I go into my DS, and DS is just a register, so I'm going to change that to current step, and at least that'll look correct. So I think we're okay. So let's connect up, and we're good, and we don't want to read it, and typically we never want to read it unless we don't have any program and we want to see what's in there right now. So we're going to write the project into PLC, and syntax error. So let's take we need a reset on our sequencer too. So I need to go in here, and this will be my system reset. So this will be my X003. And you know, anytime you see on any of these things, if you see this little stub into, you know, our output or our action that we're trying to do, that means it needs to be connected. Now we aren't using new step, so there is no stub there, so we don't have to worry about that. That was kind of easy. I can just look at that and say, well, that's not connected, and you know, I should know that anyway. So let's do the line thing. Okay, now we should be ready to write project into the PLC. And I guess here I don't have my end instruction, so we'll go into put it in there. And now, hopefully, without further ado, we should be able to load it into our PLC. Okay, that looks a lot better. And we're going to say transfer is complete. And we want to go into run. So, and this number, we had the wrong register, and I'm sure that was just the initialization thing for why that says 10, but we reset it anyway. We saw that we needed to do that. So now when I hit start, we're going to have our lamps, and you can see in here the lamp test will go on for 3 seconds, and then it immediately is going to go to yellow. And then when that finishes, we'll get the sequencer done, and then we'll get the green lamp if everything works right. So we've got them all on. Now just yellow, 3 seconds, and now it'll be continuous green, and that's the way it should work. Now here's the trick that I wanted to show you. So what happens is, in all of these steps, we're depending on setting this and then wrapping it around and going to the next step. So when we get to step 2, we set C4, but then it gets wrapped around, and that's the event that moves us to step C5. So let me just reset everything. Well, let me just go offline for a second and reset everything. This is going to continue to run because the PLC has something in there. But what I want to do is I wanted to change this. So instead of bubbling through like here, I'm going to change this last step. So instead of it being C7, I'm going to take that away, and I'm going to make C4 continuous all the way through. And I'm going to say my last step, well actually, so C4 goes here, and we'll go to this step, and then this step. Now, because C4 is continuously high, it is not going to go to this last step. It's going to be stuck on this step here. So let's say that that's okay. And we want to download that into our PLC. Yep. Okay, and I'm going to reset it to step 1. Now I'm going to turn it on, and we're going to watch what happens here. It'll get stuck in the sequencer. So we're on here, and it'll go this step, this step, this step, and then it stops at this step. And even though we say, well, if C4 is high, we want to go to T1, it's not going to do it. And let me show you why. If we go, and it's in this event-based document, but I also have it shown in here. So the way sequencers work, you can see that they have, and this is the table from that document, all these things happen on a rising edge. I don't know how well it shows, but this is a little arrow going up. So you need a rising edge. Now, when we look back in here, the rising edge, you know, it happens when it first looks at it. The only rising edge we see here is at this step when it wraps around. It doesn't see a rising edge here, so it's going to get stuck at that point. So you have to make sure when you're doing this thing that you know, you have one event happening after the next event. And we're going to go a little deeper into that with the next thing that we're going to do, which is going to be the event-based sequencer that actually controls the light stack initialization that we use for the system. So we will do that next time. So you know, the important thing is, you know, you can use these little wait state bits that are just placeholders to move you from one step to the next if you need to, but it always needs to see a transition. You know, if you have a signal that's high here, it'll work the first time, but it's not going to work thereafter. So that's the important thing, and we'll see you in the next one when we'll do the actual light step sequence with the sequencer.